So our next question says, consider the differential equation dy over dx equals y squared over x minus 1. Now, the first question says, on the axis provided, sketch a slope field for the given differential equation at the 6 points indicated. So this should be easy. For example, all you will have to do, let's see, one of our points is 2, 0. So all you have to do is plug in 2 for x and 0 for y. And so this will equal 0. So the way that we do this is, the way that we would do this is, our 0 would be considered horizontal. So in this case, you will have a horizontal line. Now for our next point, 2, 1, we will get 1/2. So 2, 1 will look something like this, increasing. And then we'll go down to 2, which is equal to 2. 2, 2, 2. We'll see that it's increasing as well. And for 0, 0, we'll see that it's undefined, so therefore it will be a vertical line. I hope you can see that. A vertical line. Now, for 0, 1 will also be undefined, so we'll do a little vertical line right there. For 0, 2, it will also be undefined. We will do our vertical line right there. So our next part is, let y equals f of x be the particular solution to the given differential equation with the initial condition f of 2 equals 3. Write an equation for the line tangent to the graph of y equals f of x at x equals 2. Use your equation to approximate f of 2.1. So now this is an easy question. All you have to do is point slope form. Think about it as writing an equation for a line, but you have to use calculus, of course. So I use our point slope form. Now in order to get the slope, you will have to plug in 2 and 3 for your dy dx equation. So dy over dx, which equals y squared over x minus 1, will equal 3 squared over 2 minus 1, which will equal 9. So therefore, m equals 9. So once we find our numbers, we can plug in our equation. So we can plug the numbers into the equation. So it'll be y minus 3 equals 9 times x minus 2. So y minus 3 equals x times 2.1 minus 2. The reason why we put in 2.1 for x is we're trying to find the equation to, we're trying to approximate f of 2.1. So this would be our equation. And then if we want to, this will be our equation to approximate f of 2.1. And so when we solve this, we will get y equals 3.9. For part C, it says find a particular solution y equals f of x to the given differential equation with the initial condition f of 2 equals 3. So kind of the same thing, but we won't be plugging in our numbers to find a slope or a line tangent to the graph. So this would be an example of us separating a differential equation. So since we're separating, we have to get y on one side and x on the other. So in order to do this, we will multiply by 1 over y squared times dy dx, and that will give us 1 over x minus 1. So now that we have y and x separated from each other, now we can just take the antiderivative of both sides. So the antiderivative of 1 over y squared would be y to the negative squared, and the antiderivative of 1 over x minus 1 would be the natural log of x minus 1 plus c. And now we're just going to rewrite this. And now what we're going to have to do is to get rid of our negative 1. So I'm going to raise both sides to the power of negative 1. So that way we'll just get negative y equals the natural log of x minus 1 plus c to the negative 1. And now we could plug in our x and y. So negative 3 equals the natural log of 2 minus 1 plus c. And so c will be equal to negative 1/3.